Yeah, good morning, class. You are welcome to today's lesson. Today we are going to look at atoms. We're still continuing with the introduction to periodic table. So your presenter is Seydou Razak, and then my contact details is on the screen. Yeah, so let's look at our lesson objectives. So by the end of the lesson, you should know what an atom is. You should be able to list the three subatomic particles. You should be able to define a pure substance and give examples of pure substances, and you should be able to understand mixtures of elements and compounds. All right, so let's get going. We are going to look at what is an atom. Atoms are the smallest particles of which all elements are made. They are the basic building blocks of all matter. This includes your body, your hair, your organs, the earth, the sun, are all made of what? Different combinations of atoms. For example, our body is made up of what? 65% oxygen, 90, 19% carbon, and 10% hydrogen by mass. So you understand. So why atoms is known as what? Building blocks of matter. All known elements are arranged on the periodic table in order of what? Increasing atomic number. You remember when we were talking about the periodic table last week? All right, so it's still coming in here. Elements are arranged into groups. That is the vertical column. So remember, we had group one, group two, up until group eight. So they are the what? The vertical columns, and they are known as the groups. And we have what? The periods. The periods are the horizontal rows. So, and we said they were seven, and they are known as the periods. So elements within a group have similar physical and chemical properties. What does that mean? If we go to group one, starting from hydrogen, lithium, sodium, potassium. So you see that all these elements are in group one, so they will have similar physical properties and chemical properties. So if you're looking at them, they almost appear to be similar. And when they are reacting, then you expect them to also do the same thing. All right, so let's go on to subatomic particles. There are three subatomic particles that are found inside the atoms or atom. You'll remember I use the subatomic particles to explain the idea of atomic proton number either or atomic number. All right, so it's also coming in here. So there are the protons, the neutrons, and then the electrons. So what are the subatomic particles? They are protons, neutrons, and electrons. The nucleus is in the center of the atom and contributes most of the mass to the atom. The nucleus is made up of the protons and neutrons, which are called nucleons. All right, so take note. Another term for nucleon is what? The sum of the protons and neutrons. All right, now let's look at into detail the subatomic particles. All right, you see this model. This model here illustrates the what? The nitrogen atom, as there are 7 protons. So take note that there are equal number of protons and neutrons. So if you count, the protons are the positive ones. So if you count, you see that there are 7. And then the neutrons are those ones without charge. So they are also 7. So it means they are equal. Together they make up the what? The nucleus of the atom. So protons have a positive charge, electrons have a negative charge, and neutrons are neutral. So if the number of protons and number of electrons are equal, then we say the atom is what? Neutral. Okay. So if the number of electrons equals the number of protons, then the atom is neutral and does not have a charge. The atom can gain or lose electrons, resulting in a charge, and it is then called an ion, I-O-N. So for example, if nitrogen, we said nitrogen is having 7 protons, it means it's having also at 7 electrons. So if it's so this nitrogen is a non-metal, then it's going to gain. So supposing it gains 1, so it's now going to be -1. So it then becomes an anion. An anion. Okay. Then if an atom loses, if it is a metal, it will lose. And then if it loses one, it will carry a positive charge. And it will be known as the word cation or cation. All right, let's look at pure substances. What is a pure substance? A pure substance is a substance that cannot be separated into simpler components by physical methods. Examples are pure copper, oxygen. They are pure substances. So elements and compounds are what pure substances. So these are also what examples. So you see that copper is an element, is an example. So let's go on elements. An element is a material that consists of atoms of only one kind, such as hydrogen, oxygen, carbon, sodium, and chlorine. All known elements are listed on the periodic table of elements. They are limited in number and are the building blocks of millions of compounds. So take note. Some elements on the periodic table of elements form diatomic molecules. For example, hydrogen, nitrogen, oxygen, chlorine. These are called molecules of elements. So you see, it's N2H2, O2. So when we look at the difference, when we're talking of hydrogen atom, is only H. But when we are talking of hydrogen molecule, then it's H2. It means one atom of hydrogen plus another atom reacting together to give you what? Molecule, which is H2. And it exists is in what? Is a diatomic molecule. Di means two atoms. Sometimes atoms react together chemically to form molecules of compounds. An example, such as water and carbon dioxide. So molecules can also do that. They can also react together to give you what? A compound. All right. All matter is made up of particles with properties that help them to that help us to identify them. All right. Now it's your turn. Let's try to answer the following questions. A class activity: define the following: a pure substance, pure element. Give one example of a pure substance. Give one example of an element. Name the 3 subatomic particles. Provide for the following. Provide for the following subatomic particles. Provide the charges for the following subatomic particles. All right. Okay, we can look at the corrections. So we have got what? Define the following: a pure substance, an element. So a pure substance is a substance that cannot be separated into simpler components by physical means, e.g. an element, and also a compound. So an element is a substance that consists of only one kind of what atom. We can talk of carbon, nitrogen, magnesium. 2, give one example of a pure substance. So element or compound, any one of these. Give one example of an element: chlorine, hydrogen, neon, any one of these. Name the 3 subatomic particles. So we have the protons, neutrons, and electrons. So we said provide the charges for the following subatomic particles. Protons, they are positive. Neutrons, no charge. Electrons, negative charge. All right, now let's look at the lesson summary. So in the form of this diagram, so we have got what? Matter. So we are saying all matter, no matter what it is made up of what? Particles. So atoms, so we have got atoms. So matter is made up of particles, and atoms are also made up of particles. All right, so atoms can give us what? Ions. They can also come together to give us molecules. So what it means is that when ions loses, when atoms loses or gains, it becomes an ion. So let's go on. We have got pure substances. We have got what? Mixtures. So matter can simply be divided into what? Pure substances and mixtures. So if we go further, an example of a pure substance can also be divided into elements and compounds. Then when we go further, the elements can be divided into what? Metals, metalloids, and non-metals. And then when we go on, mixtures can also be divided into two, homogeneous and heterogeneous. All right, I've got have some links here for you to visit, and then you can get more information on this topic that we have just completed. All right. We'll be talking, our next lesson will be talking about compounds, mixtures and other compounds. And then we'll be talking about the concept of what? The particle nature of matter. All right. It was nice having you, and then enjoy the rest of your day.